Hi, everyone, and welcome to today's webinar on safety, brought to you by PlantServices and TPC Training. I'm Tom Welk, the Chief Editor of PlantServices, and I'd like to thank you for joining us today. This webinar is sponsored by TPC Training, the leader in industrial skills training, featuring the industry's deepest library of technical and safety content and an unrivaled portfolio of training solutions to help build a better, safer, and more efficient workforce. Now, before I introduce today's speaker, there are a few housekeeping issues I'd like to review with you. On your screen, you should see several primary sections. The upper left or audio control section allows you to adjust the volume of the presentation. Just hover over that section with your cursor until you see the audio volume control, and then adjust it to your preference. To the right, in the largest section, is where today's presentation slides will be displayed. Under that slide window, you'll see a chat section where you can chat live with fellow audience members. And at the left of the slide window is the Ask a Question box. And this is where you can type questions in for today's presenter at any time during the webinar, whether here on live day or on demand. We'll get to as many of those questions as we can during a live Q&A session following the presentation. And for those of you who are entering questions on demand, or for those questions we cannot get to in the time remaining, the speaker will be able to work with you one-on-one directly via email. Also, there's a handout section at the bottom left, and the handout section contains a link to the full set of today's speaker slides. Finally, to the left of your screen, you should see icons for additional features. By hovering over each icon, information about it will be displayed. If you have any technical problems or concerns, please type in your question in the Ask a Question box, which also doubles as our technical support box. And one of our technical engineers will assist you directly. If you need a better view of any section, you can enlarge them by clicking on the box in the top right corner of each section next to the X. If you accidentally close out a section, you can get it back by clicking the Restore icon. That's the one in the shape of an arrow in a circle. This webinar will be archived, and we will encourage you to direct coworkers to the recorded presentation. And at the end of the presentation, we'll ask you to complete a very brief survey to provide feedback that we can use to improve future webinars. And now I'd like to welcome Paul Colangelo, who will deliver today's presentation, a case study on fall and electrical hazards, the double dangers of maintenance. Paul has more than 25 years of experience in EH&S as safety director, manager, and consultant to construction, telecommunication, utility, and renewable energy sectors. He is also a certified construction, risk, and insurance specialist through the International Risk Management Institute and has created and delivered hundreds of outreach and specialized training programs across the country. Welcome, Paul, and thanks for presenting today.
Thank you very much, Tom, and I'd like to welcome everyone to today's presentation. It is a pleasure to be speaking with you today. You know, we are currently in times that we have never seen before with COVID-19. It has certainly created concerns for various types of employers across all industries. As an occupational safety and health practitioner and professional, my ongoing concern is we still have to maintain our awareness of other hazards. Fall and electrical hazards do not recognize COVID-19. They're gonna get you no matter what, so to speak. So as employers, as employees, we want to make sure that we are aware of the other hazards that pertain to our job. And whenever you're talking about the world of maintenance, falls and electrical hazards are certainly going to be a routine part of what maintenance technicians face. So, without further ado, I'm going to get into today's session agenda. It is the same agenda that you saw on the presentation invite. We're going to talk a little bit about common fall and electrical workplace hazards. I'm going to get into some of the regulatory compliance subparts that you need to be aware of. I'm going to then cover some of the industry consensus standards that are very, very helpful as guidance documents. I'm going to talk a little bit about employee training, And then finally, we're going to end it with employer safety and health programs. And I am certainly hoping to get to as many questions as I can. There is certainly a lot of content here in my presentation today, so I will do my best to get to as many questions as I can, and the ones I can't, I will do my best to get back to you in some sort of communication format. Today's learning objectives, and I want you to keep in mind that learning objectives are actually a very significant part of what I'm going to be speaking about later. We certainly want to recognize that fall and electrical hazards are always an associated hazard with maintenance. More importantly, one of my goals here today is to get you thinking organizationally about your approach to fall and electrical hazards with your maintenance staff. This can certainly apply to any of your employees, but for the purposes of today's presentation, with your maintenance folks. Do your practices actually qualify as programs? When an organization like OSHA takes a look at what you are doing, do they actually consider it to be a program? What are some of the elements of those programs, and how are regulations and standards associated into those programs? So again, definitely want to learn about the hazards, the specific hazards with falls and electrical, but again, we're going to be really taking a hard look at some of the guidance documentation and employer programs that can address these issues. So when we talk about maintenance, and for the purposes of today's presentation, we're talking about technical maintenance, equipment maintenance. We are, talking about the functional checks, services of equipment, machinery, building infrastructure, supporting utilities. This goes on day in and day out on various shifts when we're talking about maintenance. In at least one of my roles in the past 25 years, I worked for a design build maintenance firm, and I was able to see very clearly that the maintenance technicians, it clearly presented its own unique challenges with the hazards that they faced and the training that they required. So when we're speaking about maintenance, we're typically talking about at least one or two forms of maintenance. First being preventative maintenance, which is also known as proactive. Then we have emergency maintenance, which is also known as corrective and reactive maintenance. That tends to be a little bit of a higher priority when it comes to safety hazards. The maintenance can also be performed by in-house personnel or contracted services. So I'm very mindful that today in the audience, we could have folks that work for an employer that you're responsible for the maintenance team. We may be on the line with individual maintenance team members. You could work for a company, a contract company that performs maintenance for various employers throughout various industries. So I'm assuming that we have a very diverse audience on the call today. So luckily the content, the subject matter is going to be applicable no matter what industry and what type of employer you work for. Talking a little bit about preventive maintenance. When it comes to preventative maintenance, what can actually lead to incidents? Now, I am certainly aware that maintenance technicians face a host of hazards. It's not just falls and electrical. We can talk about confined space hazards. We can talk about environmental hazards like lead and asbestos. The list goes on and on. However, when we're talking about falls and electrical hazards, those tend to be categorized as high hazard. These are the types of hazards that you typically do not get a second chance. So hazard ID and mitigation is going to be critical. Some of the things that we see lead to fall and electrical incidents can be complacency. Complacency, some of even the most senior technicians that are used to doing preventative service to equipment day in and day out, they may not be aware. They may become, less aware of some of those hazards that they need to be familiarized with. Reduced job hazard analysis, JHA, that is also known as job task analysis, job safety analysis. There's a lot of acronyms that describe that. I think the message here is very clear. We want to make sure that we are protecting ourselves before we attempt to do anything in the lines of preventative and emergency service. So Any sort of JHA is going to be critical prior to your maintenance. We also see a lot of lack of PPE and improper use of PPE being personal protective equipment, regardless whether that is having that personal protective equipment available, or perhaps maybe even the technician forgot to bring it, or the personal protective equipment has been compromised. They didn't get a chance to get a replacement piece of equipment. They're using it improperly through various things like maybe insufficient training. And sometimes, as we're going to find out here in the next few slides, personal protective equipment is really not the first go-to. And I'll talk a little bit about that in a few slides down. Multitasking. We all work in the world now where we are multitasking. You could be on the phone with another technician at another site. They're looking for your advice. You're trying to do your own preventative maintenance on the equipment. Perhaps you're trying to interact with an OEM, type up a report for a client. So all types of multitasking can be a breeding ground for incidents to happen. Fatigue and stress. I don't know of any maintenance technician that I've ever met that hasn't been affected by fatigue and stress associated with shift work. I think it just goes with the territory that anybody that is in the world of maintenance can work on any type of a shift, morning, afternoon, or night. Fatigue sets in. This is very common, but the question I have for employers, do you actually have a fatigue management program within your organization? Do you have commonplace actions and policies and procedures in place that address these things? I'll talk a little bit more about this in a few slides down. And then, of course, weather and environmental conditions, where this isn't just for outdoor situations. Even the environmental conditions on an inside plant, you can be facing extreme hot, extreme cold, things like heat stress, obviously outdoor elements such as snow and ice and rain. So a variety of supporting factors can lead to incidents with preventative maintenance. I mentioned that emergency maintenance tends to be a little bit more of a concern. First and foremost, the pressure on restoration status of equipment. I have worked in industries where, the equipment, when it goes down, it could be life safety equipment with a hospital or a healthcare facility. It is absolutely critical that that equipment gets restored as soon as possible. But once again, let's just make sure we are not so focused on getting that equipment restored that we are overlooking our own personal safety. So again, that lack of job hazard analysis or job task analysis is critical, even when it comes to emergency maintenance. Available technicians not qualified. I think that most of the industry, they do their best to make sure that the most qualified technician ends up on that project or on that job. But typically, I find that relates specifically to the expertise on the equipment. My bigger question is qualified as it pertains to safety and health. And this is where training, obviously, is going to be your biggest defense with this. And we'll talk about that later in the training section. Fatigue and stress, also very common when it comes to emergency maintenance, as is lack of adequate PPE and training. Again, weather environmental conditions plays a big role. We also see a lot of non-compliance with OEM process and procedure. You're going to find that even regulatory agencies like OSHA are very big on relying on manufacturers' specifications and recommendations. Again, going back to that very first bullet, sometimes the pressure on restoration status is so critical that maintenance technicians very often overlook what is the official OEM process and procedure on approaching that restoration status, especially when it comes to personal safety. Before I get into the next section, I'm going to leave you with this slide. I thought a lot about this. The first aid ideology for maintenance. I have been a first aid CPR instructor for the better part of 20 years. Anybody who has ever taken a first aid CPR class, or if you are an instructor, one of the very first things you learned is before you attempt to treat anybody, you have to make sure the scene is safe. You certainly wouldn't attempt to give somebody CPR in the middle of a busy highway. You're not going to put yourself in personal jeopardy. It does not make sense for you to risk your own health and safety if you are going to attempt to help somebody else. Obviously, there are all types of rescue personnel out there, EMTs and police and fire. This is what they are used to doing, jeopardizing their lives. But when you approach maintenance, I'd like you to use this first aid ideology. So in this particular case, your victim, so to speak, is that piece of equipment. Well, you cannot perform your task if you haven't done a thorough job on making sure that your health and safety are not going to be compromised. Now, we all understand that jobs are dangerous. You just cannot take the hazard or danger out of a certain job, and even OSHA recognizes this. However, we can do a lot to be aware of those certain hazards. We can get training on those hazards. We can be protected on those hazards. So elimination may not be possible, but the reduction and the minimization of that hazard is very critical. So again, your safety and health come first. And again, please be mindful of that throughout this presentation and throughout your job. So when we look at common hazards, we'll address the fall hazards first. You can't really talk about fall hazards unless you address slips and trips. Slips and trips typically accompany a fall. They're usually a precursor for falls. But in the general industry, which is where OSHA classifies most maintenance, slips, trips, and falls account for the majority of accidents. OSHA estimates each year that approximately 345 workers are killed and over 200,000 are injured as a result of slip, trip, and fall incidents. I've left a lot of links in today's presentation. I am not going to be able to get into any of these links in detail because of the time constraints. However, as mentioned, you're going to have access to this presentation, and I invite you to please explore a lot of these links that I have put in here. I have left one here for the U.S. Bureau of Labor Statistics, or otherwise known as the BLS. Any statistics that you are looking for as it pertains to industry, trade, hazard, typically you can find it within the U.S. Bureau of Labor Statistics. So anytime you are perhaps looking to find out, what are fall hazards among maintenance people versus construction, things of that nature, you can find them in the BLS website. So again, I invite you on your own personal time to delve into these links. This is a chart here between 2006 and 2012. Fatal falls to lower level in the general industry. We find that year to year, it stays pretty consistent north or south of 300 fatalities. That may not seem like a large number, folks, but these are human beings we're talking about and lives. As far as I'm concerned, one is too great a number. So anything north and south of 300 is always cause for concern. So we've got to be very mindful that, again, fatal fall to a lower level, you're not going to get a second chance when it comes to falls. Some more common hazards we'd see with falls outside of the lower level. Falls into dangerous equipment, you obviously are going to be working above and below dangerous equipment all the time. Falls, every time you talk about falls, you've also got to be talking about falling object hazards that we have to be very mindful of. So that should always be integrated into your training. Contact with electricity, as the old saying goes, if the electrical contact doesn't kill you, the fall will. So anytime you are talking about fall hazard training, it is always very beneficial to integrate electrical safety into it. So, obviously today we are talking about both hazards. Holes and skylights, maintenance technicians, obviously very commonly on top of roofs, accessing things like HVAC equipment. You're always going to be coming across holes in rooftops, skylights. That is a very famous picture, actually, on this slide. It was taken by OSHA. It was a post-incident fatality. You can see the person's hard hat and personal items there on the ground. And as the story goes, the person simply sat down to make a phone call, wasn't aware of the load factor on that skylight, and I believe that individual fell 30 feet to their death. So again, job hazard awareness, job hazard analysis. And we will talk about some mitigation techniques for these. Whenever we're talking about general industry fall protection trigger height, we're talking about height of 4 feet or greater. So we're not talking about a lot of fall distance here. So bottom line is you have to have some sort of prevention or protection for your technicians if they are working at a height of 4 feet or greater. That is an OSHA requirement. We find improper ladder use. I will also add to ladder use failure to inspect. Failure to inspect a ladder properly usually leads to a lot of ladder incidents. Slips and trips, again, those typically, a majority of those typically stem from poor housekeeping. So housekeeping is another area of training when it comes to fall and electrical hazards. Unauthorized lift equipment use, I'm assuming, and I also know from experience that I see that a lot of maintenance technicians are very commonly using aerial lift equipment, scissor lifts, articulating man lifts. These tend to be a much safer approach as opposed to working off a ladder or being strapped off to a piece of equipment. The big question there is how much training have they had? Do you actually have an employer certification program on that? And another big area that we see that is commonly violated is whether or not that technician was authorized to use that equipment. It's one thing to say that you are trained on it. The big question is, were you authorized by your employer? Were you authorized by, the company that you work for or the host employer to actually use that specific piece of equipment? And then, of course, we find that inadequate training. The presence of employees on a job site alone when it comes to things like fall protection. Sometimes people look for personal protective equipment as a way to see if people have actually had training. I find that that's not always the case. If I see people that have, personal fall arrest equipment, they have, they've donned the body harnesses, that doesn't always tell me that they've been properly trained. They strictly may have been administered equipment without having adequate training. So adequate training is something that we want to make sure we do a very thorough job on. Now let's take a little look at some common hazards with electrical safety. OSHA estimates each year that approximately 300 workers are killed and over 2,500 workers are injured as a result of electrical hazards. About 98% of fatal occupational injuries are from electrical shock. 40% of those incidents involve 250 volts or less. I wish I could let people know, and again, as much as I've taught electrical safety in the past, it just seems that most people think that electrical safety applies to high voltage, which is typically 600 volts or higher. That's not the case. We see a lot of electrical incidents, injuries, and fatalities as a result of 115 volts or 277 or 480. So it's not just a high voltage situation where electrical safety needs to be looked at. The common hazards for electrical shock is usually the leading concern, contact with overhead and underground electrical systems. Then we have the situation of arc, flash, and blast. For those of you who aren't familiar with arc, flash, and blast, the simplest way I'm going to describe it for you, the simplest way I'll try to get you introduced to it is you can just go on YouTube and type in arc, flash, and blast. You can see for yourself what this represents. It's a very scary situation where any sort of arc is introduced into an electrical system, perhaps a worker with a tool or something metal that they are wearing, perhaps even a piece of electrical equipment that was improperly wired. You can have a situation where an explosion occurs, the atmosphere heats up to 35,000 degrees Fahrenheit. That's hotter than the surface of the sun. This is where you see a lot of very serious second and third degree burns occur. Blindness, deafness can occur as a result of the arc blast. It's a very, very serious situation. I am going to introduce a standard here in a few slides down that addresses arc, flash, and blast specifically. And again, the resulting burns from this condition can be very severe. We also have to be very mindful of fires and explosions and how that relates to the building infrastructure. An electrical hazard, an electrical incident can also lead to a fire, which can affect anybody working inside a building. An explosion can happen if you're working in a specific hazard atmosphere. So these are all relative to electrical safety and electrical safety training. Some very common hazards we see when it comes to electrical incidents: failure to implement safe work practices and procedures, This is usually something that happens after the fact, where regulatory agencies will want to see where you documented that. Failure to implement things like control of hazardous energies, that is known as COHE, that is the acronym, or very commonly lockout tagout, which is a form of COHE, which is also referred to as LODO. Lack of or failure to obey signage, barriers, and warnings. This is very, very big. It's not just for maintenance technicians and employers, host employers, to make sure that certain areas are labeled and those warnings are posted, but even while folks are doing their work, if a maintenance technician is interacting with an electrical system, he or she has got to make sure that they have done a thorough job with signage, barriers, and even verbal warnings. Poor illumination, this is another very common cause of electrical incidents. Poor illumination, if you can't see the electrical hazard, then something's going to happen. So we want to make sure that we have adequate illumination. If we have to work in an area where the existing illumination is not adequate, we have to make sure that we bring in temporary lighting that is. And also, unqualified workers per the NFPA 70E, that's a standard I'm going to introduce to you here in a few minutes. We don't just want to take a look at the qualifications for qualified workers. We also want to make sure that unqualified workers understand what they can and cannot do and the types of training that they need. I mean, think about it. A janitor is not a qualified worker. They are an unqualified worker, but a janitor can certainly stumble into an environment where electrical and fall hazards are present. So they do need a certain degree of that training. So let's not just look at qualified workers. We also have to look at unqualified workers as well. The last slide in this section I want to leave you with talks a little bit about fatigue. I mentioned that a few slides previous. Fatigue is a very common occurrence in maintenance and in a lot of different jobs that you see out there. Anybody that is used to shift work, there is an organization called NIOSH, the National Institute for Occupational Safety and Health. They are actually a sister agency of OSHA. They work on a lot of research and development in the industry. They published a lot of great material on fatigue management. And I think that one of the things I want to try to stress to employers is, fatigue just can't be taken for granted. It's something that employers need to look at very, very intensely and ask yourself a question. Do you have a fatigue management plan? Do you have health and wellness programs within your organization? Are you documenting things like special needs for employees that have perhaps sleep apnea, things of those natures? You'd be surprised at just how many moving parts there are to fatigue management. So if you do not have a fatigue management plan, I would strongly ask you to look at organizations like NIOSH. You can go to that link and learn a little bit more how you can develop a fatigue management plan for your organization and specifically your maintenance staff. So now I'm going to talk a little bit about regulatory oversight, and the lead organization for any occupational regulatory oversight is going to be OSHA. I would assume that most everybody listening knows that OSHA is the Occupational Safety and Health Administration. They were established in 1970. Their laws actually went into effect in 1971. They basically, in short, OSHA is there to make sure that employers maintain a safe and healthful place of employment for employees. Once again, as I mentioned in a previous slide, we know that certain jobs are dangerous. We know that certain jobs are hazardous. The big question is the statement here I'm going to make is that your employers have a duty, a lawful duty to make sure that they are doing their best to mitigate those hazards, to identify and mitigate those hazards, to reduce and minimize the possibility of your getting hurt and killed. So one of the first things I want to take a look at here when it comes to regulatory oversight with falls, your go-to OSHA subpart to identify what your compliance requirements are with falls. When you see OSHA 29 CFR, the CFR stands for Code of Federal Regulations. That is going to be for the 1910, which is general industry. OSHA actually has different categories of regulations for certain industries. For the general industry, that's going to be 1910. And then that general industry or construction or whatever industry that you're actually looking at, it's going to be broken down into subparts and sections. Subpart D, walking and working surfaces, is where you're going to find the majority of compliance regulations as it relates to fall protection. This subpart was actually overhauled, underwent a major revision that went into effect January 17th of 2017. This is known as the final rule to update general industry walking and working surfaces and fall protection standards. I have left two links here on this page. The first is the actual final rule. You're not going to see this in the actual regulations. There's a lot of robust information in this final rule that you're going to find extremely helpful on how they derived at some of these revised regulations. I've also put publication 3903. That is actually a very helpful posting that goes over some of your requirements when it comes to fall protection. This is basically the layout of Subpart D. I know that's kind of a busy slide, but you can see that it does cover general requirements and ladders, step bolts and manholes, stairways and dock boards, scaffolds, rope descent systems, fall protection systems, fall restraint systems, falling objects, and training requirements. So there's a lot of information contained within Subpart D. There's also a lot of reference subparts within this Subpart D as well. Subpart D, it talks a lot about incorporating technology, best practices, and national consensus standards. So what I'm saying is OSHA will actually reference things like consensus standards, which we will be talking about next. You're also going to see a lot of harmony with construction fall protection regulations. For years and years and years, general industry and construction, they used to have separate requirements. I'll give you an example. Scaffolds, there used to be a separate set of regulations for scaffolds in the general industry and a separate set of regulations for scaffolds in construction. Now they're harmonized. If you take a look at Subpart D when it comes to the scaffold section, it's going to tell you to reference Subpart L of the construction regulations for scaffolds. So we see a lot of harmony now with construction regulations, which is as far as I'm concerned, long overdue, and it's a great thing. A lot of flexibility with systems. OSHA used to call out specific systems to treat specific hazards. What they're really doing now is they're looking at you as the employer and saying, gather all the technology and best practices and standards, and you determine what is that best mitigation strategy for that hazard. Subpart D also has a very strong focus on hazard elimination first. You're going to find the same thing for electrical. I mentioned earlier that personal protective equipment should never be looked at first. The very first thing that should be looked at is eliminating that hazard. Now, we all know, especially for maintenance technicians, it's not always possible to eliminate that hazard. You cannot take a piece of HVAC equipment that's located on the rooftop of a building and put it down at ground level. You certainly can't de-energize a piece of equipment if you're going to have to run electrical checks and balances on that equipment. So elimination first. If you can't do that, that's where you have to look at things like engineering strategies and work practice controls, and then personal protective equipment. So let's not just jump at personal protective equipment. Hazard elimination first. They are very big on employer inspections and assessments, and in many cases, those inspections and assessments have to be written. They have to be documented, and they have to be discussed between employers, multiple employers. So this is a case where the host employer and perhaps the contracted maintenance firm, they have to share information. They have to share information about hazards and how to go about mitigating those hazards. So it's very, very common. If OSHA comes in after the fact and they see that an accident, incident, fatality has happened, they're going to look at everybody in that food chain. They're not just going to hold that one employer responsible. They're going to make sure that communication is flowing between multiple employers. A little bit of regulatory oversight about electrical. I just told you about Subpart D for falls. in the general industry, your go-to subpart for electrical is going to be subpart S. A very interesting thing about subpart S, even though it's a very robust subpart, you're going to find that most of the sections are reserved. In other words, nothing has really been done within those sections. My go-to sections for electrical safety are 1910, 330 on selection and work practices, and then 335, which are safeguards for personal protection. I also want to make sure that you are aware of Appendix A. Appendix A within the subpart has numerous reference documents, and it also references the NFP 70E, which we're going to talk about here in a minute. One of the reasons for all the reserved parts in subpart S, there is a wealth and abundance of electrical safety data out there. A lot of great best practices and standards exist. So this is OSHA's way of not reinventing the wheel. There's a lot of great information out there already, and you're going to find, I'm going to explain here in the next section about how OSHA can actually adopt by reference a lot of these consensus standards. So again, subpart S for electrical safety, please make sure you are referencing Appendix A for reference documents. Some other regulatory oversight documents that you're going to find for both falls and electrical safety that apply. Subpart E, exit routes and emergency planning. We find that this is another commonly overlooked area when it comes to training. Subpart F, powered platforms and man lifts. I just talked to you a little while ago about certifications and authorizations on certain pieces of equipment. Subpart I, personal protective equipment with special attention to Appendix B, which covers hazard assessment for personal protective equipment for fall protection. Subpart J, general environmental controls. That's where you're going to find a lot of information for lockout tagout, which is specifically 1910.147. And Subpart P, hand and power tools. You can't talk about things like electrical safety without including hazards when it comes to tools. So now let's talk a little bit about industry consensus standards. So first and foremost, whenever we talk about regulations, which are actually laws, I want everybody to realize that OSHA regulations are bare minimum laws for compliance. Whenever I hear someone make the statement that they are in compliance with OSHA regulations, believe it or not, that really doesn't tell me about your safety program. It doesn't tell me what you are doing as an organization to protect your workers. It basically tells me that you may alleviate an OSHA fine, but it really doesn't tell me much more than that. So simply making the statement that you are in compliance or you feel you're in compliance with OSHA regulations, not really saying a lot about your safety culture. We'll talk a little bit about culture here in a minute. So those laws are also written in very thou shall and thou shall not language, like typical laws are written. They really don't explain the how to comply. They basically just tell you that you either shall or shall not do the following to be in compliance. Consensus standards are really the guidance documents that one needs to figure out. And by the way, they're not the only documents. Consensus standard documents are put together by just those leading industry experts that they all come together. They offer up their best advice and all their experience in the industry, and they come to agreements on certain ways things should be approached, and this is how standards are created. So think of consensus standards as the how to comply documents with regulations. And again, those aren't the only documents. You can find things like manufacturer specifications that can be very useful as well. OSHA, and I just mentioned this in the previous section, OSHA may also utilize and reference in this industry consensus standards for guidance. They call that adopt by reference. They do this very commonly when it comes to electrical safety. What I mean by that is, even though they don't have official regulations, quote unquote, they will look at an industry consensus document and they will use that as guidance to see whether or not an employer did everything they could in protecting their employees when it came to things like electrical safety. So this is why I feel that consensus documents, consensus standards are critical documents for any employers to invest in when it comes to their safety and health program. So two organizations I want to introduce you to. The first is ANSI, the American National Standards Institute. They were established in 1918 as an engineering standards committee. They are actually the standards development secretariat for many organizations. I'll give you an example. An organization that I belong to is the ASSP, American Society for Safety Professionals. We are constantly developing new standards and practices that ANSI will adopt and publish for us. So think of ANSI as the overall publisher, the secretariat, if you will, for various organizations when it comes to ANSI standards. The National Fire Protection Association, probably the oldest and most storied organization when it comes to fire standards. They are headquartered in Quincy, Massachusetts. They have been around since 1896. They are devoted to eliminating death and injury and property and economic loss due to fires and electrical safety related hazards through codes and standards. I'm sure if you talk to any electrician, they will tell you all about the National Electrical Code. That is their Bible, so to speak. The NEC establishes many, many codes and standards out there that are referenced in the world of electrical safety. So by all means, if you are not affiliated with NFPA when it comes to electrical safety, please take a look into their website. I have left some links at the end of this presentation for your reference on that. So I want to introduce you to first the go-to document for fall protection from ANSI. This is the ANSI ASSP, the Z359 Fall Protection Code. It is currently on version 3.0 and it includes 14 standards. I cannot go into every single standard for you, but the one I have highlighted here is the ANSI ASSP Z359.2, minimum requirements for a comprehensive managed fall protection program. Any employer that is looking to develop a fall protection program or measure their fall protection program, as far as I'm concerned, that standard alone is a must-have. So if you do not want to invest in the entire fall protection code, please by all means get your hands on a copy of the Z359.2. And it is currently in, the latest revision is 2017. I just, this next couple of slides, I just kind of put here the rest of the standards within the Z359 Fall Protection Code. As you can see, the code is very big on fall protection equipment, personal fall protection, anchorage, and body harnesses and lifelines, things of that nature. So anybody that is used to using this type of equipment, or if your technicians commonly have to use this type of equipment, this is where you're going to find most of the information over and above manufacturer's specifications on this equipment. So the ANSI Z359 version 3.0, by all means, get your hands on that standard. Subpart D in OSHA regulations calls out that that Z359 standard specifically. They also call out the ANSI ASSP A1264, another great standard to get your hands on if you're trying to build a fall protection program. This one deals with walking and working surfaces, access, workplaces, floors, walls, roof openings, stairs, guardrail systems. So it sets forth a lot of great requirements over and above what OSHA has published. So the Z359 Fall Protection Code and the ANSI A1264.1. Now we're going to talk a little bit about the NFPA 70E. This is the go-to document for electrical safety in the workplace. It is currently on revision 2018. I believe they update this document every 4 years, so you can be looking at the next one. I should say I believe it's every 3 years. So the next revision should be coming up in 2021. We are currently on the 2018 edition. This document, this consensus standard, as far as I'm concerned, is one of the most valuable documents out there for building an electrical safety program. It talks about things like implementing safety-related work practices, lockout tagouts, electrical safety work conditions, planning and procedures, PPE and personal protective equipment and clothing, training requirements for qualified and unqualified workers. Let's go here into the next slide. This is how it's broken out. It's got 3 main chapters. The one maintenance folks are going to be taking the hardest look at is Chapter 2, Safety-Related Maintenance Requirements. I also highly recommend you take a look at the informational annexes A through Q. A lot of great information in the standard. Again, this is a standard that OSHA looks at specifically as a reference document. And Chapter 3 deals a lot with special equipment. Special equipment, things like batteries. A lot of maintenance technicians do checks and balances on battery systems, lasers, things of that nature. So the NFPA 70E, chock full of information on issues that you're going to need to build an electrical safety program. Here is an NFPA document, another NFPA document that is referenced within Chapter 2. It is the NFPA 70B, Recommended Practices for Electrical Equipment and Maintenance. It is on the 2019 edition. This is referenced specifically within Chapter 2, but how this standard differs is that Chapter 2 within the NFPA 70E specifically relates to personnel safety. The 70B mainly relates to safety as it applies to the equipment, but both are very, very important and very useful. So your go-to documents are going to be the NFPA 70E and the NFPA 70B. I don't think anybody that works in the world of electrical safety should be without these documents. Folks, let's talk a little bit about your safety and health training. And I specifically want to use the buzzword program. A safety and health training program. A lot of people get training programs confused with training courses. Training courses are not training programs, and I want you to continually ask yourself a question. Is what I am doing now with my employee training, does it qualify as a program? If you don't understand what a program should include, an employee training program, these are some of the things that I look at whenever I am measuring and auditing people's training programs. The first two questions I ask right off the bat: is your program ongoing and effective? Did you just do some one-and-done training, or perhaps you did some fall protection and electrical training for your workforce years ago and you haven't come back since? Or do you have ongoing curriculums for your technicians? How effective is that training? Do you have measured learning outcomes? Do you have quizzing and testing as a part of that training? Do you have employee surveys that they take to measure the effectiveness of that training? Have you talked with your first-line supervisors about observing people once they've come out of training? Do they look like that they understand the subject matter? So it's not just about saying that your employees are trained. I talk about this all the time. Saying that your employees are trained is not enough. We've got to go a little deeper. Do you have relevant content? I see this happen a lot. You know, how often do you actually take a look at the content, or how often do you actually hire, when you go to third-party training providers, do you actually look at that content to make sure that it's relevant? Is it in compliance with, the updated codes? Is it relevant content when it comes to industry consensus standards? Do you actually target and design courses and curriculum specifically when it comes to what your learning requirements are? What are your learning objectives? Specific learning objectives. If you just want to conduct fall protection training, one of my my follow-up questions is going to be, what specifics did you learn in that fall protection training? Did you actually learn how to don and doff fall protection harnesses? Did you learn all about the criteria that go into guardrail protection? Things of that nature. You can't just make broad statements to say, yes, our workforce has been trained in fall protection and electrical safety. There are a lot of different components within that training that we're going to look very hard at. How often are you evaluating those training programs? Do you provide that training in a language and vocabulary that workers understand? We have a lot of diversity now in our workforces. We want to make sure that we are implementing practices and procedures to make sure that people understand the training they're getting. Obviously, technology can be very useful today with that if you use technology. Record keeping of certificates, that's also very big. It's one thing to say that your employees are trained. It's another thing to actually prove that. Anybody should be able to run a very quick report on the employees that have been trained, how often they have been trained, and those completion certificates and the necessary information that belong on those completion certificates. So bottom line, I want you to ask yourself a very simple question. I am certain that when it comes to technical training, you spend a lot of time and money on that. You want to make sure you have qualified technicians that know their way around certain pieces of equipment. Has your safety and health training aligned with that in both quantity and quality? Here's another very useful document with designing training programs. This is the OSHA 2254, Training Requirements and OSHA Standards. These basically cut and paste all the training requirements out of the OSHA standards, and they put them into one document. They talk a lot about general industry, construction, and agricultural requirements, depending on what industry you work in, all the training that requirements for those specific hazards, falls, electrical, confined space, scaffolds, ladder safety, so on and so forth. And they also talk about training program elements in there. So this is a very useful document for designing and developing a training program. When we're looking at certain fall hazard topics, obviously I talked about hazard assessments. In many cases, those have to be written. Elimination first policies, selections of systems like prevention systems such as guardrails, covers, and personal fall restraint systems, and then protection systems that basically mitigate the effects of a fall, such as personal fall arrest systems. Fall hazard topics also include scatter and laffold and aerial lift inspection and use, personal protective equipment, competent and qualified worker criteria per the ANSI Z359 Fall Protection Code. In many cases, hands-on applications are critical. It's not just classroom environment. It can't just be e-learning and distance learning. In many cases, when it comes to fall and electrical safety, they want to see hands-on application, learning how to interact with certain pieces of equipment. So you can't always implement all the training through the classroom or through technology. Of course, virtual and augmented reality help a lot with that these days. We've learned that from the whole COVID-19 pandemic. Also, I talked a lot about emergency action planning. You can't talk about fall protection and electrical safety without talking about EAP. So we're going to do our best to make sure that the incident doesn't occur, but my question is, what happens if it does anyway? Do your workers, have they been trained on rescue and evacuation and first aid and communication? You have to make sure you include that within your training curriculum. Electrical safety topics, obviously another elimination first situation with hazard assessment for shock and arc flash potential. Electrical safety work conditions, establishing shock and arc boundaries, which are going to find specifically laid out within the NFPA 70E. Arc flash labels and equipment criteria. I'm sure a lot of maintenance technicians come across electrical equipment that's labeled. Sometimes they come across equipment that has not been labeled. Whose responsibility is that to label that equipment? You're going to find that information out within the NFPA 70E, as well as the criteria that go into those arc flash labels. Again, a lot of COHE, control of hazardous conditions and lockout tagout, personal protective equipment and protective fire ratings on clothing, and anything that concerns high voltage work should all be part of an electrical safety curriculum, as well as competent and qualified and unqualified worker criteria per the NFPA 70E, and once again, emergency action planning as it pertains to fall protection. Again, you cannot talk about fall and electrical safety unless you include EAP criteria as well. I've got a mindful eye on the clock here, and I know I'm running a little long here, but I'm going to try to finish up here talking a little bit about program criteria. Anytime we're talking about program design, whether it's training or overall, we also have to take a look at two more standards. One is the ANSI Z490.1, Criteria for Accepted Practices in Safety, Health, and Environmental Training. These talk about adult learning principles, also known as ADDIE. ADDIE stands for Assess, Design, Develop, Implement, and Evaluate. These talk about things like needs assessment, audience evaluations, learning objectives, program administration and evaluation, and also qualifications for instructors. So this doesn't just talk about the actual content of your program. It's how you actually go about designing your program. Program administration, things like, do you have a budget allotted? You know, what goes into that program for technology? What sort of training programs do you have for your instructors? We all know what it's like to have a bad teacher, whether it was elementary school or high school or college or any one of those mediums. But the question is, that instructor may have been very well versed in the subject matter, but how were they with delivery? What was their delivery technique like? The ANSI Z490 talks a lot about these adult learning principles. You're going to find out very quickly that adults don't learn the same way children do. So it's not just about procuring the best content, and if it's relevant content, it's how we actually are going to design and develop and deliver that content. So this specific standard can be very, very helpful in helping you do that. The next standard is a very recent standard, just came out last year. I actually sat on this committee for ASSP. This is the Z490.2. Anybody now that is dealing with augmented reality, virtual reality, a lot of our instructors out there are now having to realize that they just can't do in-person training anymore. They have to now be trained in practices on how to implement AR and VR. So this standard can be very, very helpful in helping you determine things like learning management systems, how to choose one if you are looking to either partner with a third party or perhaps purchase your own. Any sort of e-learning content sources, what to look for in choosing an e-learning content provider, and also the ins and outs of augmented and virtual reality technology. So again, two very helpful documents in helping you structure your program. So I'm going to talk very quickly now. I'm going to finish up here about safety and health programs. Some of the things that need to go into your program, some of the checks and balances. You need to make sure that you have a documented program. You need to make sure that you have competent and qualified program administrators. You need to conduct workforce needs assessment. You have to have allocation of resources. You cannot tell me how effective your program is if you cannot explain to me that you have a budgeted allocation of resources for that program. The program has to be measurable. I talked a little bit about that as well. It's got to have certain devices of measurability. You can't just tell me that because you had no accidents and injuries last year that, you can't show me those incidents of measure that you compare those to. Sometimes, you have to ask yourself a question. Was it because of an effective program, or was it just blind luck that nobody got hurt or killed? The program has to be all-inclusive to your employees and your contractors. So everything from your CEO down to your most recent new hire, even your contractors, they have to all be included in these programs. You also have to have enforcement measures. Unfortunately, despite our best efforts to develop a program, we have to ask ourselves a question. When employees or contractors willfully do not abide by our program, what do our enforcement measures say? What are the issues that we are going to implement? What are some of the results going to be here that we're going to take a look at why somebody didn't willfully comply? There has to be a consequence for noncompliance. And your program has to be evaluated at least annually. Anytime I see a program in effect, don't show me a program that you developed 10 years ago and you haven't come back to it since. It's very, very helpful that you evaluate it at least annually. Here's another great link for OSHA, recommended practices for safety and health programs. They recommend that you actually have 7 elements to your program: management leadership, worker participation, hazard ID and assessment, hazard prevention and control, education and training, program evaluation and improvement, and communication and coordination for host employers, contractors, and staffing agencies. I talked to you a lot about multiple employer responsibility. It is spelled out right here in this document. Fall hazard programs, I'm going to go right back to the Z359.2. If you are looking to develop a minimum requirements for a fall hazard program, you have to look at these controls that are within this document. So again, please get your hands on this document, the Z359.2. It is invaluable. And if you are going to develop an electrical safety program, I'm going to come right back to the 70E. Please take a hard look at the following annexes: Annex E for electrical safety program, Annex F for risk assessment and control, Annex G for sample lockout tagout program, and Annex H for selection of protection clothing and PPE. These aren't the only annexes, but these are by far the most helpful, I find. The last thing I want to leave you with, folks, is when it comes to developing programs, don't just think that you have to do this internally or organically, on hard paper. There are a lot of workforce management systems that can help you do this. A lot of great technology exists out there for program management, hazard incident reporting, contractor pre-qualifications, mobile documentation, record keeping, and safety and health skills and training design. So a lot of workforce management systems and software out there. It's very invaluable when it comes to helping you do this for a program. Here are my reference documents. I hope that this information has been helpful to you. I know I ran a little long here, probably didn't leave a lot for a Q&A, but I'm going to turn it back over to you, Tom, and my apologies for running a little long.
Oh, no problem. It was a information-packed presentation, and I want to encourage everyone who's listening today to download the slide deck if you do want this set of information on your PC or on your mobile device. Paul's slides are available in the handout section to download, and you don't want to miss out on all the resource documents and standards documents that he reviewed today. We'll move to close out. Paul, no time for questions and answers today, I'm afraid. So, Paul, first off, thank you so much for this presentation. Safety is a high engagement topic for PlantServices audience, and I appreciate your presentation today.
Thank you very much, Tom. I want to thank again everybody for listening in. I hope the information was beneficial. Again, my apologies for running long, and I want to thank PlantServices for hosting this webinar and TPC Training for sponsoring it. And just wish everybody a safe and healthy summer. Thank you once again.
Yeah, and I'd like to thank TPC Training too for making today's presentation possible. Would you like to see this presentation? Please let us know your thoughts by answering a brief survey that will appear on your screen shortly. Once again, your candid answers are not only appreciated, they help us craft future and better events. So once again, thanks to Paul, and thanks to TPC Training, and thanks to everyone who attended today. Have a great rest of the day.